Yes, the next topic we have the magnetic field due to a current carrying a circular coil. So far we have seen only in straight conductor we have seen. Now we have changed the shape of, right? So if the shape is changed, what about the direction of magnetic field we are going to see here, right? And the previous session we have seen about right hand thumb rule, right? The same principle we are going to use here. At the last I have drawn one circular shape, right? The current will flow in circular shape. That is a basic principle of this one. Okay, and here we can move on to the topic directly. So the last session I have drawn the circle as this way, right? The current flows in the anti-clockwise direction I have mentioned, right? And the same diagram I am going to invert it as like that. Okay, so this is the circular coil, right? And here I indicate plus and minus. Then the current flow will be anti-clockwise direction. Current flow in the direction of anti-clockwise, because current is always will start from positive terminal and end with negative terminal, right? And here the current is flowing in the anti-clockwise manner, right? So anti-clockwise. As I said earlier, the top portion will be always north pole and south pole. So change this diagram here. So this is in the anti-clockwise direction current flow. Then left hand side should be north pole and right hand side should be south pole. So here I am indicating the magnetic field lines in the upper portion, right? And what is this one? Yes, this is small concentric circles here we have, right? But practically how it will be in the sense, this will be as somehow bigger lines, bigger circles, and this one is somehow much bigger circles. And what about this one? Yes, very much bigger circle. If you are seeing very much bigger circle, it will be look like, yes, straight line. It will look like straight line. And very good example, we have Earth. Earth is a very good sphere, right? Yes, it has a big sphere, right? Can you able to see we are in the big sphere? Yes? No, right? You can able to see as in straight line, yes? As flat, straight. It's not a circulating one, right? So the circle is very much bigger. So it will be look like a straight line. So exactly at the center it look like straight line. And here you can only able to see the a part of the circle. But here you can see the full circle. Right? In the upper portion all are showing that north pole to south pole, again south pole to north pole. So outside north to south pole, inside south to north pole. Right? And lower portion it will be the same. But the direction gets changed. This is in clockwise manner, but this is in anti-clockwise manner. The magnetic field lines are, the magnetic field are in anti-clockwise direction, right? So note down here the direction of this one and this one both are in opposite direction. This one is clockwise and this one is anti-clockwise, right? So try to understand here. This is a basic concept of a circular coil here, and so the magnetic field will be produced here, right? What is this concentric circle is indicating? Yes, of course you know. These concentric circles indicating magnetic field. Yes? Okay. As we have seen the straight line conductor, as the distance is increases, magnetic field will be decreases, right? As the distance increases, the magnetic field will be decreases. That is the first concept in the straight line conductor. And second concept, what is if you are increasing the current value, what is the magnetic field value? It is also increasing, right? It is also be increasing, right? So if current increases, magnetic field also increases. The same two concept is applied here also. But one more thing we have here, one more concept here. Here I have drawn only one circular, right? Suppose if I have more than one circular coil, what will happen? Yes, of course, the magnetic field value will be increased. If you have number of turns, okay, this is one turn, single turn, right? If you have 10 turns in the sense, or as in that single turn has 0.2 Tesla magnetic field resistance. If you have 10 turns, 0.2 into 10, that will use 2 Tesla. So we are increasing the magnetic field value. So what is the application of this circular coil? Yes, of course, solenoid. Here we are going to see later onwards. Okay. So try to understand the concept here. As the distance increases, magnetic field will be decreases. Current increases, magnetic field is increases, and turns, number of turns is increases, magnetic field value also increases. Yes, and here I have draw the same diagram, but here I mentioned one plane of paper. Okay, this is the current direction in anti-clockwise direction, and here I connected one circuit minus plus minus plus minus plus battery. So the current is always flows from positive terminal to negative terminal, right? Yes, so it goes here and connected here and come back to here, right? So here it will be look like this one. Yes, this one, right? Which is in the rotating in the anti-clockwise direction. Okay, and this one is clockwise direction, right? So apply right hand thumb rule, and one more rule here we are going to use Maxwell car screw rule for circular coil also. How I can say about, yes, assume that this bolt as a screw, okay, and my forefinger as a screwdriver, okay. I am applying some force to derive this screw, right? So what is a driving a screw? Driving a screw, that indicating current direction, and this is my forefinger indicating current direction, and this car is rotating, right? Yes, that the direction of car screw is indicating the direction of magnetic field. So this question they may ask in 2 mark question also, either right hand thumb rule or otherwise Maxwell car screw. So assume that this forefinger is screwdriver, and this screw I am going to apply the force to derive it. So driving a force that will give the direction of current, this direction, and the screw will rotate like in a circular shape. So that will indicate magnetic field. Suppose if you want to lose that screw, what will happen? The direction of current in the opposite direction, right? That time screw will rotate in the anti-clockwise direction, right? Yes, clear? Yes. So the basic concept here is R increases, magnetic field value decreases, I increases, magnetic field value increases, and the number of turns increases, magnetic field value also increases, right? So this is the basic concept for solenoid, right? I hope you understand well.